Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all my panels. My name is Muhammad Hafizuddin bin Razeli, and I'm supervised by Prof. Dr. Ahmad Yusairi. Today, I would like to present about my final year project, which is development of a drone that is capable of gentle landing. First of all, I would like to talk about table of content. There is 5 content in this table, which is first, problem statement, and then objective, methodology, result and discussion, and lastly, conclusion. So, for the problem statement, we all have seen a quadcopter in the sky lying so majestically in one location until it drops like a rock. But there is a problem. For example, when the drone fly high and suddenly it loses power, and after that it will fall to the ground. So this is the example video of the drone when it loses power and fall off to the ground. So, due to this problem, the drones can become unmanageable, fall down and land on hard surface. Next, we move to the objective of the project. First, to implement safety features in drone technology system. Then, to develop a parachute system for the drone to land safely in case it loses its power. Then, to design the circuit of drone parachute system using Arduino. Next, we move to the methodology. So, this is a flowchart of my project. First, we identify the problem statement and doing some literature review. Then we start do the hardware development and continue to the software and sensor development. Then we start run the system testing. Then if the system testing is okay, then we move to the result, experimental result and analysis. Then lastly, we start doing project report. Next, I want to tell you about working principle of my project. First of all, the drone will be switched on and it will operate successfully. Then after several minutes, the drone battery will drain slowly. After that, the voltage sensor will detect the voltage drop from the drone battery. So, if the voltage drop below 1.0 volt, the voltage sensor will send information to the Arduino, which act as the head of system. So Arduino will command the servo motor to rotate 0 angle to 90-degree angles. Then the door will automatically open and parachute will be popped out. So the airflow will put the parachute in shape so it can reduce gravitational force, so that the drone will land safely to the ground. So next, we move to the development of software system. So for my project, I use Arduino IDE software to write and upload coding or programs to my Arduino, which is Arduino Nano. Next, we move to the software design flow process. So this is my flowchart for software design flow process. First, we turn on the power, and then when the main power voltage or main drone battery detect the voltage low, so the parachute will deploy. So next, we move to the block diagram of my project. First, input, and then process, then output. So for my input, we use voltage sensor as input, and then Arduino as a process, then for the output, we use servo motor. Then for the development of hardware component, I use 3 electronic component. First, I use Arduino Nano. So Arduino Nano as a microcontroller for this recovery system. Then I use servo motor. So this servo motor is used to open the parachute casing. Then last, I use voltage sensor. So voltage sensor is used to determine and measure the voltage supply. So for this project, I have draw 2 design, which is parachute casing and then circuit casing. So for these 2 drawing, I use Autodesk 360 Fusion software to draw this design. Next, we move to the result and discussion. For the hardware, this is drone specification. For the drone body battery is 3.7 volt and 1800 milliampere modular battery. Then for its charging time, about 160 to 180 minutes. But for the use time is about 8 to 10 minutes only. So for the size, for the expanded size, it's about 25 cm times 25 cm and 5.5 cm. Then for the folding size, it's about 12.5 cm times 8.1 cm and 5.3 cm. So for the material for this drone is ABS raw material. Next, for the parachute casing specification, I use acrylic board for the material. Then the size is 5 cm times 5 cm and 5 cm. Then this parachute casing have 2 door with hinge and 4 holes for airflow and 2 cylinder pipes. Next, for the circuit casing specification, I use same material, which is acrylic board for this circuit casing, same as parachute casing just now. Then the size is 3 cm times 3.5 cm and then 8 cm. So the function of the circuit casing is to protect the electronic circuit. For example, to protect the circuit from rain. So for the parachute specification, I use plastic as the material for the parachute, and then the size of parachute is 35 cm for the radius, and then this parachute has 8 thread which attach to the plastic, and then this parachute is functioned to support the drone during the fall off. So for the project prototype, so this picture shows us fully compiled of 3 components. So first, the parachute casing. So inside the parachute casing we have the parachute and then the drone. So the bottom one is circuit casing. So for the drone and the circuit casing, we attach using book strip, and then for the drone and the parachute casing, we attach using 3-second glue. So this one is top view, front view, and then side view. So for the software result, so this result I got from serial monitor from Arduino IDE software. So we can see that there is voltage drop from 9.2 volt to the 0.2 volt. So this one is a schematic diagram of my project. So this is data analysis for my project. So this one is drone battery reading, and then the servo motor, then parachute status. So when the drone battery is more than 1 volt, so the servo motor does not rotate. It will remain 0 angle. Then the parachute does not deploy. So then when the drone battery is less than 1 voltage, then the servo motor will rotate from 0 angle to 90-degree angle. Then the parachute will deploy. So the project is tested by using 9 volt battery that act as drone battery. So when there is a connection with the battery, we can see the voltage is 9 point something volt. So the servo motor won't rotate because the voltage is above 1.0 volt. So if we remove the battery from the connection, we can see the voltage drop from 9 point something volt to 0.2 volt, and the servo motor will rotate from 0 angle to 90-degree angle. So we can see it works from this video. Next, we move to the conclusion for this project. So first is the implementation safety features in drone technology system is accomplished. Then the development of a parachute system for the drone to land safely is successful. Then a circuit connecting the voltage sensor with Arduino Nano was fully designed and developed. So last but not least, for the recommendation of my project, in the future, we can change the material of circuit casing which can reduce the weight of load to support the drone. Next, solar energy can be used as the power source for this recovery system for self-charging. So this project will be more efficient as it is integrated with the battery and solar charger controller. So the battery can be used as a backup power supply, especially when the solar panel is unavailable during nightmare. So this will save power consumption. Next, we can adding a battery capacity monitor to improve this project. So the user will be able to monitor the battery voltage to predict the remaining energy and runtime. So battery monitors also can collect and display other data such as power consumption, current consumption, and battery temperature. So that's all from me. Thank you.